pre-calc, let's take a look at the quiz that you took and go over the solutions. Okay, the first problem here is making common bases. So what you want to do is make sure that both your left and your right hand sides have the same base, which in this case is going to be 5. So we've got 5 to the x cubed minus 7x. Over here I'm going to write this as 5 squared. A power to a power is powerful, so I multiply. But I'm going to have to bring this one upstairs. Okay, 5 is not the same as 1/5. So 5 to the x cubed minus 7x equals 5 to the negative 2x power. Okay, if you have common bases, then you have exponents that are equal. Okay, and then we're going to go ahead and move everything over to one side. When you have a cubic, it means you're going to get 3 answers. Add 2x, that makes negative 5x equals 0. Okay, I'm going to solve a cubic by factoring out an x squared minus 5. Okay, and then we're going to keep factoring this quadratic into x plus radical 5 and x minus radical 5 equals 0. Our 3 solutions are 0, x equals negative radical 5, x equals positive radical 5. Okay, let's go over how to graph an exponential function. Okay, the first thing I notice is there's a negative on the exponent. So I'm going to go ahead and write that as a positive exponent and then reciprocate that base. I'm going to graph this basic, which is a decay, okay, and then I'll do a transformation. I always want to see 3 points, 0, 1, 1, 1/6, and then negative 1, 6. Okay, so let's go ahead. All exponential graphs have an asymptote on the x-axis. 0, 1 is right there. 1, 1/6. Negative 1 takes us up to 6. This is definitely decay. Okay. Now, the transformation that they wanted us to show, okay, was negative 4. That's 4 units down. So the asymptote is going to go ahead and go 4 units down. Okay. Every point, 1, 2, 3, 4 units down. 1, 2, 3, 4 units down, 4 units down. This is still decay, it's just shifted down. Okay, he does have an x-intercept this time. Make sure I can see your 3 points. Okay, the next problem that I asked you to do was solve using the log circle. 2 to the power of 3 equals radical x. 2 to the third power is 8 equals radical x. There's a couple ways you can do this. Okay, to undo a radical, you can square both sides. Okay, and x equals 64. You also could have said that the radical means a half power. Okay, which means I will square both sides. Power to power so powerful that we multiply. And no matter how you do this problem, you should get 64. Okay, take a look at number 4. Okay, find the domain. Whenever you have a domain problem, I want you to take the of. Okay, I want you to take that of, and I want you to write down an inequality that says greater than 0. Since this is not a power or a denominator, we're just going to go ahead and solve by subtracting 7. I'm going to go ahead and divide both sides by negative 1. Don't forget to flip the sign, and x is less than 7. Okay, number 5, another domain problem, but this time we have a fraction. Okay, this is a rational function because x is in the denominator. He's still greater than 0. The way that you solve this is with a number line. The critical values come from the numerator and the denominator, so we've got negative 7, okay, and we've got positive 3. They're both open bubbles because it's a greater than symbol, and now I'm going to test the sections. A number here I'm going to test is negative 10. Okay, negative 10 minus 3 is negative, divide by negative. So this section is coming out positive. So I'm going to go ahead and color that in. Okay, this middle section right here, I'm going to test the number 0. We've got negative over positive. This is coming out negative, but I want greater than 0. So that's not good. I'll test positive 10. That gives me a positive over a positive. So another good section. Okay, final answer here. Negative infinity to negative 7. Union 3 to infinity. All right, let's take a look at number 6. Can you solve a log equation? Okay, I'm noticing here that there's a log, and a number. I can't set the ofs equal, okay, and they're on opposite sides. So the first thing I'm going to do is move this natural log to the other side, subtract it over, and move the 2 to the right side. Now I can do that thing. I can combine 2 logs into 1 log. Okay. Now what do you do when you're stuck with a log? A log circle. The base is e to the power of 2 equals x over 7. I'm going to put e squared over 1, and I'm going to cross multiply. Okay, so x times 1 is x equals 7e squared. So that's what x is equal to, 7e squared. And the last one. I noticed that there are 3 logs. The first thing I'm going to do is combine 2 logs. I can combine 2 logs into 1 log. Okay, on the right hand side, I'm just going to leave him for a second. And what do you do with the ofs? When the logs are added, I multiply them. Now I've got log equals log, 7 equals 7, so of equals of. I'm going to solve the quadratic by moving everything to the left. Minus 9. And I hope this factors. Let's see, 2x and x. Let's see if I put minus 1 plus 9. That makes 18 minus 1. That's it. So the answers are 1/2 and -9. You have to make sure that your solutions are correct. Okay, if I take a negative and I plug it in right there, I definitely know it's not going to work. Does 1/2 right there work? Yes. A half right there? Yes. What about a half right there? What's 9 minus 17 times a half? 17 halves. That's smaller than 18 halves. So that's going to come up positive. So the only solution here is 1/2. I hope this helps.